Hello, plant taxers. My name is Stephanie Brandt. It's nice to officially meet you if I have not yet done that. Today in this video, I'm going to be talking about fruits and inflorescences. Listen up for this first part one. I'm going to talk about fruits. First and most importantly, all flowers will produce a fruit. Every single fruit that you have ever known came from a flower. That is a direct correlation. And specifically, the fruit comes from the ovary of a flower, right? Remember, the ovary is part of the gynecium, namely the part that holds ovules and seeds. Those ovules become seeds while the ovary becomes a fruit, as you can kind of see as with what's going on in this picture. This is a picture from your Jepson manual. These glossary pictures are also available online. In fact, you can just Google image search them or find them on the Jepson site. Now, what you've already talked about in a previous video is sort of the ovary wall. And that is the part that's going to become the fruit. And then down here, we've got sort of a bunch of different options for different types of fruits. We're going to talk about a couple of these and some other ones. So namely, this ovary wall, it'll actually become this stuff that we call pericarp. So the entire ovary becomes the fruit. The ovary wall is what becomes the pericarp. Sometimes this pericarp is fleshy, delicious. Other times the pericarp is woody, papery, all sorts of textures. Cool. Back to this first picture that I showed you. One of the most well-known types of botanical fruits out there is a berry, of course. Things like watermelons are berries. Things like tomatoes. It's going to be anything that's fleshy entirely throughout the fruit. And it's going to have seeds sort of embedded within, usually multiple seeds. And oftentimes berries come from a syncarpous gynecium. Remember, that means multiple fused carpels. Berries. Here's sort of another look of a berry. If I were to draw the pericarp of a berry, I would just sort of have to draw it like this, where it's just entirely one color, all fleshy throughout. And then those seeds are just embedded within the pericarp. That's what a berry is. Fleshy throughout, straightforward. Now, this type of fruit is considered indehiscent. This is a word that just means it doesn't open. The opposite of that is dehiscent, and that means that it does open. Back to the indehiscent fruits. Berries, again, you actually know lots and lots of berries. Things like tomatoes. They are not only absolutely not vegetables, they're berries. They're fleshy, and they've got seeds. There's no hard part, like you see in drupes. Now, a drupe is similar to a berry, but in a drupe, the pericarp, it's fleshy on the outside, and there is usually just a single seed on the inside, but that seed is surrounded by other pericarp tissue. This pericarp tissue that I'm drawing in red, which is really truly derived from the fruit, like I'm saying pericarp, this is considered the stone or the pit, which all drupes have. That's what sets them apart from berries. You can see that in this picture of a peach. The next indehiscent type of fruit I want to talk about is the achene. This is usually a very, very tiny little fruit. You can hold a whole bunch of them in your hand. I don't even know if you can see this one in this picture here, but this person is holding one achene. They can be even much smaller than that. What an achene is, if I were to sort of draw my diagram, sorry, these are not the greatest diagrams in the world, but you should look up other diagrams on your own. In an achene, first of all, they're very small. Second of all, they are not fleshy. And third of all, really, the seed is just inside of a pretty thin pericarp. These diagrams are bad. First time working on this type of software, and I'm going to work on that for you, I promise. In an achene, the fruit wall, it's not fused to the seed. It's very thin. And this is sort of why these types of fruits resemble seeds. It just sort of looks like a seed. But what has happened in this picture down here is the person who was designing this photograph, they removed one of those seeds from the achene. And so in theory, there'd be sort of like a papery, tissuey piece of pericarp. That's the actual achene that this seed was inside of before they removed that to take the picture, to show the seed is basically the same size as the entire fruit. Cool. Moving on. A Samara, it's just a winged achene. That's it. Not going to spend much time on it. Usually kind of flat. Usually it's winged because its function is to sort of catch the wind. Do not Google image search this term. Just take my word for it. It's just a winged achene. It's a single-seeded, very thin pericarp. Moving on. A nut is a little bit different because it's got a much thicker wall. Should I stop with these diagrams? It's just thicker. So the proportion of the fruit wall to the seed is going to be a bit bigger. So in a nut, the seed is sort of smaller relative to the fruit wall. Also, usually nuts are from a syncarpous gynoecium, while achenes tend to be from a single carpel. Finally, a dehiscent fruit. This is a capsule. Now, spoiler alert a little bit here, capsules are probably the most common type of fruit that we see in the angiosperms out there. We see them all over the place in plant taxonomy. Now in this picture on the left here, this is just the flower, the sort of younger version of the picture on the right. So the only part in this first picture that actually will be sort of part of the second picture is this right here. This is the long style. And we can imagine right down there below those sepals, there's an ovary down there. That ovary is what is going to be mature and become this dehiscent fruit. This is called a capsule. And now what we can tell from this picture is that this capsule is derived from a syncarpous gynoecium. We can actually just tell by looking at this picture because we're sort of seeing these walls. These are actually septa, or like singular. This is a septum. And then we've got sort of the ovary walls here that are very woody compared to some of the other fruits we've talked about. You can really, really clearly tell that this is from a syncarpous gynoecium when you look at this small, tiny, itty-bitty diagram up here. Because we've got kind of a complete circle on the outside before it opens. I don't know if that makes sense. Let me try to draw that on this one. Here's another picture of those capsules. So here's your pericarp. This is what I'm drawing here. This is like the moment before it opens. I need to get a way to just like fill this color in. Okay. And imagine there are sort of these lines. You can see them on the outside of the fruit. And maybe, I don't know, maybe there's 4 of them. Maybe there's 8 of them. Maybe there's 2 of them. You can sort of see these indentations. And it just so happens that maybe the next day, let's say, this arrow represents time, this fruit, it has dehisced, meaning it has opened. And it's opened on those splits. So this isn't going to look very good. But you see what I'm kind of trying to do here? It's opened on all of these splits. Right, right here, and here, and here. Those 3 things are like here, and like imagine there's another one on the opposite side. They've split. Now, this line before it split, like here I'm going to highlight one of those in red. This is called a suture. The suture is kind of visible just before it opens. Once it's opened, the capsule has split on the sutures, and now what's visible are these, here, I'm going to highlight them in green, these sort of pieces of tissue here that have separated apart from one another. You can actually maybe more clearly see it in this little picture here. These are called valves. V-A-L-V. There's 3 valves in this picture because they've dehisced. To 3 parts. Moving on. Capsule is from a syncarpous gynoecium. Here's another picture of just sort of an example of one. This one does not just open up. like the other ones, it's got little openings sort of under these that we can't even see. And so I just wanted to show you a little bit of diversity of capsules. You can do a Google image search of this. That will be safe. Just Google image search like botany, capsule, angiosperms maybe. And you'll see lots of diversity of them. This one looks similar right off the bat. You see this, you're like, oh, it's open. There's the seeds. So it's dehiscent. Yes, you're right. This time, though, a follicle is different from a capsule because a single follicle is from a single ovary. A single simple ovary, meaning not a syncarpous gynecium of multiple fused carpels. That's not what we're seeing in a follicle. One of these structures right here is one follicle, and it is derived from one ovary. Okay. Now we've got 1, 2, 3, 4, 5 follicles in this picture. All 5 of these came from a single flower. That might be sort of weird and hard to believe, but it is. And to help you believe that, I've attached a picture of the columbine flower, that these 5 follicles are derived from that one single flower. So that means that those 5 carpels are separate, or these 5 ovaries are separate. That's the difference between a follicle and a capsule, because they're both dehiscent. Remember, you can have 3 carpels, but they can be situated in 2 different ways, right? When all 3 carpels are fused to one another, you have a syncarpous gynecium, and that's just one pistil. On the other hand, when you have 3 carpels again, but they are unfused, they're separate from one another, that's when you have an apocarpous gynecium. So, about those apocarpous gynecia, here's a picture of a flower where, I know it's hard to see in this picture, but right in the middle of all of those stamens, we can see the gynecium, little tiny young ovaries. This is what they have matured into, this sort of pom-pom looking thing. It's actually very small, but you can see in this picture that's made up of tiny individual units. That was not a syncarpous gynecium. This one is, in this picture. Here, when you have a syncarpous gynecium, it's going to mature into one simple fruit. One flower, one fruit. Here's another example of that. Here, this one's a capsule. Flower is on the left, the matured ovary is on the right. Back to that buttercup. It's from an apocarpous gynecium. We can tell because we can see individual units. And so this is a zoomed in picture of sort of one of these, right? Well, one of these, this zoomed in picture of one of these, that's an achene. That's that fruit type that we talked about earlier. The entire aggregate of an apocarpous gynecium of achenes is what we call an achenetum. And moving on here to the next slide, here's another well-known example of a different type of fruit that's derived from an apocarpous gynecium. And we've got, in the last slide I had showed you an achenetum, a aggregate of achenes. Here we have an aggregate of drupes. So we call this a drupetum. And there's also something called a follicetum. That's an aggregate of follicles. Actually, the picture I had showed you a few slides ago of follicles was a follicetum. It was an aggregate of them. It was 5 of them. Okay, so aggregate fruits are derived from an apocarpous gynecium. One flower. Now, a multiple fruit is very crazy. It's complicated. It's uncommon. It's when you've got multiple gynecia from totally separate flowers. Multiple flowers, right? You've got these ovaries fusing to one another during fruiting. So you can kind of see what's going on in this picture a little bit. But one well-known example of a multiple fruit, the only well-known example I can think of, besides maybe dogwood, is a pineapple. Maybe you've never thought about the fact that pineapples actually originated as a bunch of tiny, tiny flowers. So the picture on the left is just a young version of your pineapple fruit. Cool. And what happens is all of those ovaries in this inflorescence here, they merge, they fuse into one another, and then they just become this one giant, delicious, juicy pineapple. One entity from multiple fused flowers. Okay. Now, like I said, this is a cluster of flowers over here on our left. That is my segue to part 2. Inflorescences. Working on controls. Notice this picture is from the Jepson manual as well. Please reference that. This is a good summary, and just kind of highlighting, say, one of these. This inflorescence type is a head inflorescence, and notice it's got this sort of stalk and then this expanded part, and then what you see are these little half circles. These are a bunch of flowers. And so a head inflorescence is when you have a cluster of flowers all close to one another, and they don't have individual stalks on them, on those flowers. Okay, so check out that glossary. I'm going to show you a few more examples here in just a moment. Wanted to go over some terms first, starting with a flower. Okay, you guys know that now. Flower, well, the stalk of a flower right here. This is called the pedicel. Let's do that in this color, Pedicel. All right, this part right here, the part that's sort of holding all of the pedicels, that's attaching them to one another, this is called the rachis. I also hear it pronounced rachis sometimes. That makes sense too. Now, we see these little tiny structures at the base of each pedicel here. These little pieces of membranous tissue. These are bracts. Bracts, that's a C. Bracts are just usually small leaves associated with flowers or associated with inflorescences. Cool. The last term here on this picture is the base, the stalk sort of below the rachis, below the lowest flower. This is the stalk of the entire inflorescence, and it's called, I love saying this word for some reason, it's called a peduncle. Say it with me. Peduncle. Oh, you're not here. That's okay. Moving on. You've got all these types of inflorescences. There are lots of good good photos and glossaries. So I would like for you to sort of look at those on your own, please, because I'm going to whiz through these right now. 2 that are similar. Notice a raceme, which is on the left here, and a spike, which is on the right. They're both these unbranched stalks. Okay. The difference is that a raceme has pedicels. So it's sort of hard to see in this picture, but each one of these flowers is attached to that rachis by a pedicel. In the picture on the right, each one of these flowers is directly attached to that central rachis, which is not visible in this picture, of course. But these flowers, they do not have a stalk. They are sessile, in other words. They don't have a pedicel. That's what makes it a spike. A raceme, again, that's when you've got one elongate axis with multiple flowers attached along that. A panicle, I like to think of it as a panicking raceme. It's a really branchy inflorescence where it's not just one stalk. That stalk will branch multiple times. And sort of the other main branches will stalk, etc., etc. That's a panicle. Now, umbel versus corym. I like to talk about what's kind of similar first. In an umbel, all of these flowers are sort of more or less like maybe coming up to the same height, or maybe they are all the same length or something like that. But in an umbel, all of the pedicels are directly attached at one singular point. That point in this picture right here, right? All of those flower stalks are attached right there. In a corym, which is the picture on the right, we've got all of the flowers attached in different points along an elongate axis. But in a corym, what tends to happen is the flowers all come up to the same height, approximately, and they're sort of flat-topped in that way. Cool. Cyme is a very complicated one. Thought I'd save it for last. Here's a little picture on the bottom left. What happens is this branch, the original stem, or I guess at this point you'd call it the peduncle? Yes. This one terminates at a flower. So this is the very first flower. It ends up being the oldest flower as time goes on, right? And so as this flower, this is the same one right here. As time has gone on, though, there's been some growth, and now we've got 2 younger flowers underneath. Now, those 2 younger ones, those are equivalent to these, right? That first one is still that big central one in the middle. Now, again, branching has happened, but that branching has happened below its next oldest flower. Crazy, complicated. We call these determinate inflorescences. Like a cyme is a determinate inflorescence because that very first branch terminates at the oldest flower. It sort of determines the height of that stem, if you will. And I think that's my last slide. Thanks for watching.